Hi, everyone, and welcome to this presentation from the UK Terrestrial Evidence Partnership of Partnerships, but a bit more on that soon. It's good to see so many of you here today. Today we're going to talk about the importance of prediction, and it's a collaboration between JNCC Science Talks and the annual UK TEPoP Festival of Events. This event is being recorded, so please keep your camera and mic off, please. And instead of using the chat function, we ask you to use the Slido to ask your questions throughout the presentation, and we'll answer to them at the end. You should be able to click on every link present during this presentation, so such as the one at the top here for the Slido. So a bit of context. First, the UK TEPoP Festival 2025 is a series of 4 different workshops and webinars on different events. Please register for the last 2 events if you are interested. Also, just so you know, you can rewatch all those different events on our TEPoP YouTube channel. And if you have any question or for further information, do email us at tepop@jncc.gov.uk. So for those who are a bit less familiar with our work, so across the UK, the primary sources of national species evidence are species monitoring scheme, through which volunteer citizen science collect huge quantities of data. A huge range of taxonomy groups are monitored to various extents, from larger schemes, bats or birds, right through earthworm or through other recording scheme and societies supported by the Biological Record Center. Many of these national monitoring schemes, or the one here with the logo, are run through partnerships between JNCC, non-governmental organizations, and the UK Centre for Ecology and Hydrology. The 4 country nature conservation bodies invest in these schemes through JNCC and are actively involved in steering and advisory groups through for the schemes. So what is UK TEPoP? So until 2017, JNCC was a common partner across all these national monitoring schemes. However, we recognize that many of the challenges or opportunity relevant for engaging volunteers with monitoring one taxa are also often relevant for another taxa. So it would be beneficial for organizations working across the space within the sector to work together. So with all our partners, we established a UK Terrestrial Evidence Partnership of Partnerships, designed to bring together all these organizations involved in funding, organizing, running, and steering to collaborate, exchange ideas, and work together on shared challenges effectively. But today is about the importance of prediction and specifically how we can use the data collected through the different monitoring schemes for prediction. So today we are joined by Chris Cheffings from JNCC, Anita Lazurko and Rob Cooke from UKCEH, and James Pearce-Higgins from BTO. So further ado, I'll pass over to Chris. It's working, Chris, but you're muted.
Sorry, yep. Thanks, Hélène. I'm just going to give a really quick overview before I hand on to the main speakers today. So I suspect many of you will not have heard of the Biodiversity Pathways project, which is a context that we're going to be presenting within today. So this was another JNCC partnership project, which we started back in 2022. Actually, as a part at that time of the Terrestrial Surveillance Development and Analysis project, which aligns with and works alongside UK TEPoP. So that has now been so successful that it's spun off and it has its own governance and multiple work areas. But the key thing it does is thinking about how we can use all of our biodiversity data and evidence to predict possible different futures. And through doing this, to flip the narrative from being all about long-term decline to one in which, if we choose the right pathway, we can start to predict a positive future of nature recovery. So if I take just a very quick theoretical example, this is the UKBI looking at butterfly data. So I could just continue approximately that current trajectory line and say, well, is that what the future looks like? And would that be how I would consider like a business as usual trajectory? Well, maybe, but maybe not, because that trajectory is based on the sum of all of the pressures and changes that have occurred in probably several years. So that's where I've drawn the blue box there. And so within that time span, there will have been habitat gains, losses, changes in management systems. There'll be changes in pollution and climate change as well. So if we actually predict a continuation of that trajectory, we would be saying that all of those pressures and changes would remain exactly the same. But we know in reality that they are already changing. We are seeing more habitat gains as we get creation initiatives going, but climate is worsening. So if we then layer on top of all of those changes that are happening anyway, some of the biodiversity policy changes, how do we consider those trajectories? And the future is also going to hold changes in agricultural systems, and some of those could be positive, but some of them could be less positive. So we really need to think about how we build these trajectory lines, and how we can think about the data. So if we want to know the effect of habitat creation, we need to know approximately which habitat, what it's going to replace, how it's going to be managed, and where it will be. And only then can we start to think about what that might mean for species. So these are all aspects that we're very, very interested in exploring further in the Pathways project, but I promise to keep things short today because we're going to hear from three much more qualified speakers than myself. And so I think I'm going to ask Anita if she would like to now take control of the slides. Anita.
Okay. Hi, everyone. Thanks so much for joining. It's a great turnout. So my name is Anita Lazurko. I'm a transdisciplinary scientist at the UK Centre for Ecology and Hydrology. And a lot of my work is using some sort of scenarios, futures, foresight methods to try to inform our understanding of the future of different sustainability challenges, climate resilience, nature positive, etc. So I'm coming at this from perhaps a different lens than many, where I wasn't trained originally as an ecologist, but I'm learning from you all as well and trying to bring some of these ways of thinking and frameworks in. So Chris and Selene introduced the Biodiversity Pathways Project. So I won't do that, but I will just say that some of the ideas that I'll be presenting were inspired by and also explored within, to some extent, this project. So the outline of my talk here, I already gave a very brief introduction. I'll talk through what are scenarios, so just get the definitions out right away, and the rationale for why we should use them. And then I'll go into a little bit around using scenarios to inform biodiversity projections, though I know some of the other speakers are going to give you more in-depth case studies of how that's gone for them. And then some of my key recommendations in terms of areas of future work from my angle. In my work. So yeah, what are scenarios? So we often define scenarios as plausible descriptions of the potential future trajectories of a system. They can be this tool to explore the uncertainty of the future, and they're often presented through plausible stories or narratives that really paint a picture of what that future looks like. So that includes describing drivers of change that can be as far away from biodiversity as geopolitics or economic change, etc., and then also looking through that, the interlinkages of that to possible implications on drivers of biodiversity loss and outcomes for people and nature. They can be qualitative in these narratives. We do link them to models, and we also use semi-quantitative methods to both develop them and evaluate them. But a bit of a disclaimer, despite the name of this talk or this webinar, they are not predictions of what the future will look like. They are projections of that scope of future possibility that we need to look at in order to make better predictions. And for those of you who might have used scenarios in the past, people often associate these 2x2 matrices, and if you know what I'm talking about, then you'll know they're not always that. There are a lot of methods and tools used to develop them, and that can include stakeholder engagement and transdisciplinary methods. It can include looking at complex systems interactions. So there's a lot here that we kind of encompass in this term scenarios. And apologies for the fuzzy slide, but this is the classic typology of 4 types of scenarios in the IPBES methodological report on scenarios and models. And this is kind of embedded within a decision policy cycle. So at the agenda setting stage, you might have exploratory scenarios where you look at plausible futures of what could happen. And then when you're looking at policy design or decision making, you might look at a desirable future. So in our case, that might be nature positive, and what pathways there might be to achieving it. When it comes to implementation, you might test out how different policies fare against some sort of target. And then at the review stage, you might look back and see the gap between what could have happened had other choices been made. And so why do we need these type of scenarios to inform biodiversity projections? And Chris set this up really nicely. We live in a very uncertain world. This is from the World Economic Forum Global Risks Report. The kind of top perceived risks in the next 2 to 10 years. You can see biodiversity loss and ecosystem collapse way up on the uncertainties, but it's also there amongst a bunch of other things, including conflict, misinformation, critical change to Earth systems beyond biodiversity, extreme weather, inequality, etc. And these are all highly uncertain and influential to the future of our Earth system and our local communities. But these risks are also highly interconnected. And so you'll see this is another figure from this risks report, biodiversity loss and ecosystem collapse, this green circle in the top left. And that is influencing and influenced by a lot of these other uncertainties that are outside of the scope of traditional environmental science. So looking at migration, human well-being, et cetera, et cetera. So we have all of this uncertainty and complexity to deal with when we're trying to look at future outcomes for biodiversity. And in the midst of all of that, we're also trying to improve the state of nature. So this is a classic figure looking at net positive by 2050 and then full recovery by 2050. So this asks us to really interrogate what desirable futures look like and how can we actually get there. And so I really like this figure, so I can't help but present it. This gives you a sense of how scenarios and futures thinking can help us really thoughtfully navigate that future uncertainty, where we have now and everything beyond the present moment as this future potential moving forward in time. And this basic extrapolation, or the perpetual now, being this business as usual. So that might be that trend line that Chris was showing on her slide. And beyond that, we might look at a scope of uncertainty based on probability, using current trends that we understand from historical data that we can determine are likely to happen. But even beyond that, especially when you bring in these socioeconomic dynamics that we aren't always able to quantify, there's plausible scenarios or plausible future potential based on current knowledge that we know could happen, but we actually can't assign any probabilities. And then there are even further scopes beyond that. So this is like this full uncertainty space that we're trying to make sense of and situate ourselves within when we're trying to make projections or predictions. And when we're looking at nature positive, then we're trying to situate ourselves in the preferable zone, i.e. what we want to happen or what should happen. And some of that might be more easy to imagine than others that get further outside on the edge of this scope of future possibility. And so in order to kind of look at those kind of futures, I often advocate for folks to also allow themselves to really imagine and use some creativity and the sides of our brains that sometimes we don't nurture so much in our jobs. And this is a famous author of Infomocracy, who is a really deep thinker about the future, who says that if you look back 60 or 70 years from now and think of people who might have been trying to imagine the world we're in today, it is unimaginable. Even the people who are most connected to technology would not have pictured this world and what the internet has done to change it. So really emphasizing that to look at that future, we need to be imaginative. The second is that this is a really highly uncertain world that we're trying to make sense of. And another science fiction author, I quote science fiction authors because I think they're some of the deepest and most sophisticated thinkers about the future, but we can talk about that in the Q&A if you want. How many combinations of unintended consequences and human reactions to them does it take us to detour us into a future that seems to defy any obvious trend? Not many. That's why predicting the future accurately is so difficult. And lastly, we're trying to grapple with complexity. So Thomas Homer Dixon is a really famous political scientist thinking about the complexity of our world. And he says we can see our world as it is, in many ways becoming more complex, fast-paced, and unpredictable. And so he talks about how, in essential respects, our world has changed its character. And I think in our effort to make biodiversity predictions or projections, trying to grapple with this complexity is increasingly important. And so when we're using scenarios to inform biodiversity projections, my entry point is often through transdisciplinary futures and scenarios approaches, where we're situating the use of scenarios in these broader projects that are producing actionable knowledge that has to go beyond traditional disciplines. So projects that are trying to answer really big picture questions about how do we get to nature positive by 2030? How do we get to net zero by 2050? And we bring together different disciplines and perspectives to do so. And what we find is that scenarios can be a really excellent sandbox to grapple with that complexity and then move toward quantifying it and making it decision relevant. And so that's my entry point. There are people who bring scenario expertise in other ways, but this is kind of how I'm used to doing things. And there's been, and there are experts in the room who will have more knowledge about this, but there's been significant progress advancing the use of scenarios to inform especially global biodiversity projections. So there was this really seminal paper that was published, I think, last year, looking at projections to the year 2050. In 2010, there was a publication from a subset of these authors kind of scoping out the framework for doing this work. And this framework, while global scale in this study, is kind of similar to how we do this at national, regional scales as well. So where you start and where I live is in this green box at the top, scenarios of socioeconomic development pathways. So that can be exploratory scenarios, looking at the full scope of possible futures, things that we like and don't like, and looking at those future uncertainties. For example, how local economies, social change, politics, etc., change. And then those are used to feed into projections of direct drivers. So often land use change, but others. And that helps translate that kind of qualitative storyline of what the future could look like into something that our biodiversity projections can actually use. And then that's where you move down to this purple box where you're making projections of impacts on biodiversity at the species level or habitat or functional group level changes. And then those can also then inform impacts on ecosystem services. And ideally, then you're able to feed that back and enrich your understanding of the future socioeconomy as well. And so kind of from my standpoint, there are a few things that I think are interesting avenues to scrutinize when we're thinking about the future of prediction in biodiversity and nature. The first is that gaps persist in scenarios of indirect drivers of biodiversity loss. So that green box at the top, some of the scenarios that are often used as the default still don't really paint a very good picture of the role of biodiversity in nature in this complex web of interactions between our biophysical system and our socioeconomic system. So in one study, what we did was try to enrich the shared socioeconomic pathways, which are socioeconomic trajectories from the climate community, with considerations of biodiversity and nature, to try to show how biodiversity kind of feeds back and influences socioeconomic trajectories. Biodiversity is not just an impact. And when we did that, we saw a substantial increase in the complexity of the system within those scenarios and actual shifts in the relative significance of different indirect drivers across scenarios because of these feedbacks with biodiversity and some other sectors that we considered. Also emphasizing that there are transdisciplinary approaches that we need to innovate and try to really explore transformative options for biodiversity. So within the BioNext project, which we talked about quite a bit in biodiversity pathways as well, we've been making that effort to envision desirable futures, nature futures for Europe in 2050, co-develop just transition pathways to achieve it. Then we've run that through a set of models to look at implications on biodiversity, but a number of other indicators, and to see whether those visions were achieved. And what we found was that they weren't. And then we had to go back and reiterate and reinforce those just transition pathways to try to get closer. We're modeling those again, and then they'll inform transformative action recommendations and guidance. And lastly, this is a really fast evolving field, the use of scenarios and foresight to try to look at the outcomes for the environment and biodiversity. A lot of different methods, frameworks, answering different questions. So within biodiversity pathways, what we tried to do was produce a guiding framework to use scenarios to explore nature-related policy questions, trying to build a bit more intention and transparency into all those framing and methodological choices that we're having to make along the road to answering particular questions. And so this is just kind of a step toward a bit more coherence in this field as we try to enrich this understanding. And so I think I'm probably right at time. So I'll just very quickly say some of my key recommendations. So increasing attention to reflecting the complexity and uncertainty of the future in scenarios that characterize indirect drivers of biodiversity loss, including trying to bring in some of the more recent science around nonlinear interactions and feedbacks across different scales and systems. So this is a huge question that none of us will answer ourselves, but I think there is work and more work is required. Leverage and improve expertise translating qualitative scenario narratives into modeling that can then inform biodiversity projections. So we do a lot of this, and it is like difficult and messy, and some of those of you who've done it before will know that. And making this more systematic and a bit easier for others to take up is important. Bringing together transdisciplinary teams of researchers and stakeholders to explore those nature positive futures. There's a lot of folks doing this, especially using the Nature Futures framework, which IPBES has released, so more attention there. Being transparent about assumptions and methodological choices, which should always be aligned to the urgent societal questions we are trying to solve. And bridging research communities innovating on scenarios and foresight and on these biodiversity projections and the modeling to really build a common language and encourage more innovation in this space would be great. So apologies if that was really fast, but hopefully I got some interesting things across. And yeah, looking forward to the Q&A. Thanks.
Thank you very much, Anita. Now, Rob, if you want to take control and take over.
Yeah, thank you very much. Thanks for having me, and thanks, Anita, for covering lots about scenarios. That was very useful for me in this setup, and I am one of these case studies of an example of projecting biodiversity into the future. So I'm Rob Cooke. I'm at the UK Centre for Ecology and Hydrology. I'm an ecological modeler working on lots of different biodiversity projects, but I worked on this project that's now finished called SPEED, where we were trying to look at plausible futures for British biodiversity. And this was with a lot of other people and a lot of other institutions involved. So we sort of, we have evidence that biodiversity is in decline, especially in Great Britain. We have this historical patterns. We have data on declines in abundance, declines, increasing extinction of species globally and at national scales. And this has kind of driven the momentum towards this need to halt biodiversity loss and also bend the curve of decline. And this is about kind of, but to understand if we can bend this curve of decline, we have to think about the future, because we know biodiversity is currently in decline. So somewhere in the future, hopefully there's a point where we bend this curve. So we need to start thinking about projecting forward and thinking about using our historical data and our understanding of what's gone on before to think about what could happen in the future. And biodiversity forecasting or biodiversity projections using scenarios can kind of help us understand what are the main differences, what can help us bend the curve, what limits us in achieving these goals. So this is where the SPEED project came in. The SPEED project was actually much larger than just biodiversity. It was because the UK kind of lacked these coordinated, spatially explicit projections of different environmental drivers like climate, land use, and pollution. And they wanted longer term projections of these. So we have climate forecast in short term, but we wanted longer climate forecasts, long-term land use, so up to 2070, 2080, what might land use do under different scenarios. And we wanted to, as part of SPEED, we wanted to provide this kind of more accurate spatial projections and have them consistent across all these different facets. So these different attributes from soil and water and air to climate and including biodiversity. And then hopefully these models and these outputs and this kind of framework of producing scenarios can be used by others to make better projections of what could happen under different exploratory scenarios. So they started in the SPEED project with these shared socioeconomic pathways, and we were thinking of this is in the context of these exploratory scenarios. So they're ideas of plausible futures. So what might happen under a set of circumstances. It's not trying to predict what will happen. It's not trying to forecast exactly the future for the socio-political world in Great Britain. And so they built these kind of SSPs with different aspects and different attributes that could tell you something about if we follow this kind of path and these sort of things happen, we might end up here. So this is SSP1, which is focused on sustainability, SSP2, which is sort of a middle of the road, which is not business as usual, but more about a balance between the different exploratory scenarios, SSP3, which is regional rivalry, SSP4, which is inequality, and SSP5, which is this fossil fueled focused development. There's a lot of depth to these SSPs that I won't cover here. But they're just sort of different socio-economic constraints under different policies and under different social division or less division that lead to different outcomes, both socially and, which you'll see, for biodiversity as well. And also as part of SPEED, we produced climate projections under different RCPs. So RCPs are relative concentration pathways, a different type of pathway looking at the concentration of greenhouse gases and the likely climate impacts of this. So RCP 2.6 is basically the Paris Agreement of a global 1 degree sort of raise in temperature, and RCP 8.5 is a more extreme climate change scenario that sort of links more to like a 4 degree rise in temperatures globally. And again, we projected these explicitly for the UK. And then we used an agent-based modeling approach to produce land use projections. So these were under a set of plausible futures. So these are combinations of these RCPs, these climate scenarios, and SSPs, these social pathways. So that together, so it's unlikely to have high climate change and a very sustainable social pathway. So they're realistic combinations of these two things. And through these, we could make spatially explicit land use projections. So using, so you can see that the amount of woodland or the amount of agriculture varies quite strongly between these different plausible futures. And luckily, these all this was produced before I sort of came in to the project a bit more. And they're all the things that are needed to make biodiversity projections. So this is the kind of overall framework of how I made these biodiversity projections. It's sort of complicated, but in general, it's just simply it's kind of combining this structured biological monitoring data. So from structured surveying with environmental data into these models. These models are generalized dissimilarity models, which sort of capture the compositional dissimilarity between different grid cells and their environmental dissimilarity. So are they much warmer? Are they wetter than this other location? How does the species differ between those locations? And then when you have these baseline models, you can project them to the future using projected climate data, which we'd produce as part of the SPEED project. And then this in itself can give you a few different metrics of biodiversity change. So we had compositional change, which I won't focus on here, and two others that we're looking at disappearing bioclimates. So bioclimates here are the combination of biological species and the climate scenario and the climate conditions, and novel are these new combinations of biology and climate. And then using another set of models, we can also turn this into species heading for extinction. So this is the biological monitoring data we use. So we use structured data from the National Plant Monitoring Scheme, from the UK BMS, and from Breeding Bird Survey. And you can see the different levels of coverage across the UK, but all of this data give us kind of structured inventories of species in different locations with different environments. And through these, we could combine this with these environmental covariates. So we had some topographic variables that were kind of fixed, and then these climate variables that shift through time. So capturing different aspects of climate, like temperature and temperature range and precipitation and the amount of sunshine. And then we built these models. So these are the generalized dissimilarity models. And they're fitted to the structural data, the structured biological data. And they sort of tell you how much change you expect per unit of environmental dissimilarity. And yeah, the main thing to take away is kind of this, they all fitted surprisingly well. So over 10% explained deviance is quite good normally for GDMs, because composition is incredibly hard to capture the variance in. So it's really high, especially for the birds, which are showing this really nice fit for the baseline. So the baseline was 1980 to 2010, all of the data in that period to try and capture what's currently in these locations across Great Britain. And then here's some results. So yeah, we projected disappearing and novel bioclimates to the year 2070 under a low climate change and a high climate change pathways. And you can see that for plants, you get this high amount of novel bioclimates. So these are bioclimates that are not similar to anything currently existing in Great Britain. So they're a new combination of environmental conditions and species. So it could be a very hot heathland with a different set of plant species, for example. Whereas for birds and plants, birds and butterflies, we can see there's mainly these disappearing environments, disappearing bioclimates, especially in upland areas. So it's kind of this loss of these alpine communities. So disappearing is where they exist in the current, but they don't exist in the future. So there's nothing similar in the future projections. And under high climate change, we can just see this sort of exacerbated for most of the groups, and this combination. So these disappearing plant bioclimates are being replaced by novel plant bioclimates. So it's this kind of replacement of what we know with what we don't know. So it kind of encourages this kind of risk of a different system and different combinations of species with new climate and new environment that we don't quite understand, and that we don't observe in Great Britain today. And then we see this interesting pattern for birds, where we sort of see a separation of disappearing climates in the north and in upland areas, and these novel bird communities in the southeast. So there's tons to unpack in these results, and yeah, this paper is currently in review that goes into a lot more detail of breaking down all these different results in these different ways. And then we also have species heading for extinction, but the main one to take away is the kind of plant one, which is the best illustration. That under kind of the worst future, which was the worst future for all of the groups, is this RCP 8.5, SSP5. So it's this fossil fueled high climate change scenario. And we see losses of kind of, over 190 species of plant and 31 species of bird and 7 butterflies from Great Britain under this scenario by 2070. And you can see that it sort of accelerates from 2030 to 2070. So we see lower levels of extinction, and it kind of accumulates through time. And then we see these different best scenarios in the future for the different groups. So for plants, it is this RCP 2.6 SSP1, which is sort of what you would expect. It's a low climate change, more sustainable society that's leading to better outcomes for plants. But for butterflies, they kind of like the high climate change when it's together with land use that doesn't negatively impact butterflies. So RCP 8.5 and SSP2, and the birds are tending to find medium climate change, but with this SSP2, where they're obviously benefiting from the land use structure within that scenario. So across the kind of whole results, I've tried to summarize them a bit here, we have this clear case that biological monitoring data can inform future biodiversity projections, especially this structured data that can kind of characterize these environment-species relationships. We find, these widespread levels of novel and disappearing bioclimates. So basically, the world is changing. By 2070, we might observe outside, we might observe systems and ecosystems that we don't recognize. And with this, these extinction debts are accumulating through time, especially for the plants. And then we see consistently that RCP 8.5 SSP5 is the worst scenario. So this is high climate change, unsustainable land use, and weak environmental protection. So maybe these are things that we can avoid if we want to bend the curve of biodiversity loss. But we don't find a single best future. But some of them are clearly better than others for our taxonomic groups. And to achieve these kind of best futures, it was clear that we need land use reform, and particularly a reduction in meat demand and increasing woodland cover were the key markers of these best futures. And then also international action is needed. If we meet the Paris Agreement, which is approximately RCP 2.6, it reduces the extinction risks to 32% for plants and 20% for birds compared to this worst scenario. So it really makes a big difference if we can mitigate climate change and limit climate change. Yeah, and then overall, conservation must adapt to change. We find evidence of change, whatever scenario we follow, and we might need these more adaptive, forward-looking strategies. And then, yeah, this accumulation of extinction risk means that the next 20 years are quite decisive. Which scenarios you start to follow dictates where you end up in 2070 with very different outcomes for biodiversity. And these speed scenarios, yeah, provide this kind of robust, spatially explicit modelling for national biodiversity planning and highlight the need for these integrated multi-sector responses. So that's including climate and pollution and land use all in together in models where possible. And that's everything. Thank you very much.
Thank you very much, Rob. I'm going to pass over now to James.
Thanks very much and good afternoon, everybody. So I'm going to conclude this by just thinking about a few different examples of where we've used biodiversity projections to come up with different examples of using models to address different questions. So next slide, please. So I want us to think about, and if you could just cycle through the options, Selene, what we're using biodiversity projections for. So building on what Anita was saying, we're looking to understand how the future might change, to predict the consequences of different decisions, and to then explore how those different decisions might change under different futures. And I want to illustrate this, if you click again, just with thinking about the weather forecast. So this is actually what the weather forecast according to the Met Office was for now. So you can look out your window and see if it's accurate or not. And we obviously use this to think about how the future might change. If we're trying to be warm or dry, we might think about our clothing and predict the consequences of the clothing that we might wear in our ability to stay warm or dry when we go outside. But actually, obviously, the dependence of our clothing is dependent on what the weather forecast is. And therefore, we might have different consequences of how we're feeling when we go outside, depending on that combination of what the weather is going to say and what we are wearing. And I'm going to hopefully unpack each of these three elements with different examples. Next slide, please. So the first of these, very much building on what Rob's just talked about, actually is some work we did a few years ago now, projecting the impacts of climate change on bird populations and communities. So very much modelling the abundance of birds using the breeding bird survey data in the UK, and also using data from France. And the reason for using the French data is to enable us to better parameterise the relationships between climate and bird abundance for climates that are not currently found within the UK. And we were also not just looking at responses to climate change, but also factoring in variation in land cover using the Corine land surface, because we were needing to incorporate data from Europe. Next slide, please. So what this enabled us to do was, if you take a species like curlew, model the current breeding abundance of curlew on the left-hand side here, so on the present. So you can see very much a kind of northern and western upland distribution. And then if you take medium climate change scenarios equivalent to about sort of 3 degrees warming or so by 2050s and 2080s, you can see that northwards range contraction and decline as illustrated by the graphs on the left-hand side, where the orange dots indicate declines under a medium scenario, red under a high climate change scenario, and blue under a low climate change scenario. So this is a northerly distributed species that we know is for which climate change is one of the pressures that they're facing that is likely to continue to worsen with climate change. Next slide, please. And then if we take another species, a grey heron, this is a species that we know their populations tend to get knocked back by cold winters, and so actually has benefited further with respect to climate change. So we see these populations likely to increase. Next slide, please. And then there are other species, potential colonists coming across from Europe. This is again the value of incorporating some of that European data. And this species here, the Zitting sicicola, is one, if you click through, projecting to actually start to colonize by 2050. And if you click again, the new was actually a breeding record on the Suffolk coast this year. So it's a species that our models were expecting would colonize the UK, and we're already starting to see evidence of that. Next slide, please. And these predictions, of course, are really valuable to think about the vulnerability of species and communities and habitats to climate change. So you can see here very much species occupying those upland habitats, and our breeding seabirds as being particularly vulnerable to climate change, being at medium and high risk, and other habitats such as our woodlands or wetland habitats showing more of a mix of species, some likely to benefit from warmer temperatures and others likely to decline. And this kind of evidence is really important to inform decision making. Next slide, please. So in this example, I've shown how the combination of land cover and climate data enable us to model abundance, and this enables us to provide metrics that relate directly to indicators and community structure and inform likely indications of future kind of conservation prioritization. And by including that continental data, that enabled us to better characterize likely future responses to those novel climates that Rob's just talked about. And this approach can be developed further to think about how you can respond with different land cover scenarios as well under those different climate change scenarios. Next slide, please. So now I'm going to switch tack and think about testing some specific policies, and here particularly drawing on work by my colleagues Gavin Siri-Wardner and Joe Cooper, who've developed these BIMLA models, which are really a policy scenario assessment tool that have been developed through the ERAMP and EVAST projects for delivering integrated modelling platforms to look at policy responses in Wales and in England, incorporating land cover management and again breeding bird survey data. And capturing the unique relationships between those species and their environment. Sorry, with some of the formatting doesn't seem to have quite translated across here, so apologies for that. Next slide, please. So here the models are created either at the parcel level or at the landscape level, and then if next click, please. We use those revised information to model the abundance of birds at a 1 kilometre resolution. We make those predictions for the baseline and then apply future predictions, predicted scenarios for those moving forward. Next slide, please. And here's an example of the kind of outputs that you can get. So it's very specific species projections, where for many of those species as shown in green, you've got predicted population changes with 95% confidence intervals. Many of them are predicted to increase in response to this particular intervention compared to those in grey, where there's uncertainty or no effect and a small number of species likely to decrease. Next slide, please. And these kind of outputs can be used to then produce, again, sort of indices, multi-species indices. Here, for example, showing an equivalent of the all-species bird index for the species that were modelled. You can track through the purple line that historical context, and then explore what a couple of scenarios of different policies would give you with relevant uncertainty, as shown by those A and B letters on the right-hand side. Next slide, please. So just to summarise what this approach has shown is that the BIMLA models have been used to process over 60 government policy scenarios over the last few years. With ongoing work, so really helping the government to provide that evidence to understand the potential biodiversity consequences of different scenarios. One of the challenges we've had with this is trying to parameterize those for rare or novel land uses, but we're actually addressing that through targeted survey work, for example, on miscanthus. Climate change is not included directly in these models, only through associated changes in land use, and as noted, the modelling is more challenging for rarer species, or as I said, for scenarios with changes in rarer habitats. And I'm not really able to give you much more detail than this because some of the specifics in terms of the particular interventions are restricted due to sensitivities. Next slide, please. But another example I want to highlight is work we've done within the urban environment using bird and working with butterfly conservation UK BMS data to model the relationships between the built aspects of the built environment and bird and butterfly populations to try and inform spatial planning. Next slide, please. And here, what the graphs on the left-hand side show you is for a range of different aspects of the urban environment, looking at landscape composition at the top. So things like the amount of built environment there is, where these large numbers of both bird and butterfly species show negative associations with that. That's the blue and the purple lines. And if you go down as habitats associated with trees and woodland and so on, which show more positive associations. And broadly speaking, what we find here is that aspects of the built environment is negative for biodiversity, but you get richer communities where you've got more gardens and green spaces. And we're able to use these models to then take real world housing development plans and predict the biodiversity impacts of those, and also to play around with some of those scenarios. Next slide, please. So, for example, if you in this example, if you pack in more houses into a particular area, but then expand the amount of green space in response, what impact does that have on biodiversity? Does that have an overall beneficial effect? And the answer is it depends on the context. So because of the modelling approach we take here, you get different responses depending on whereabouts you are in the country and the different species assemblages. Next slide, please. So these outputs are really valuable. It's a growing area of work for us, and particularly what we're keen to do is to use this to kind of link back to the biodiversity metrics that are used for kind of offsetting, but with real world predictions and data. These are well validated models. And so I think there's significant potential to help inform what we do in the built environment moving forward. Next slide, please. And then the final example I want to talk about is again from the Biodiversity Pathways project that Chris and Anita introduced. And here we've been doing some work modelling potential ways of reaching the 30 by 30 target, looking at, again, breeding bird surveys, using the breeding bird survey data to do this. But the framework that we've used here has got potential to be extended to other interventions. Next slide, please. So we're taking a number of different approaches to how you could expand the protected area network, either distributing it randomly, by expanding that protected area network to kind of focus on larger sites, improving the conservation value of national parks and AONBs, or on the right hand side there, maximising the representation of habitats, so targeting habitats that aren't well represented in protected areas at the moment. Next slide, please. And then predicting the consequences of that for biodiversity. And you can see in the different countries, generally expanding the protected area network has a more positive effect on more species, so more red bars than we've got negative effects and blue bars, but the precise benefits of that in terms of those different options varies between the different countries. Next slide, please. And if you then look at the overall predicted changes in abundance over about a 10-year period, you can see those tend to be modest but positive in each country. So expanding the protected area networks will have a positive effect on biodiversity. But additional modelling work that we've done through that project is demonstrated that actually you can really ramp up the benefits associated with the protected area expansion if you maximise your amount of targeted conservation effort on those protected sites as well. Next slide, please. So a few conclusions here. Again, emphasising that the vulnerable species, so the rare habitat specialists, are the ones that benefit most from those expansions of protected areas. Targeted species conservation can accelerate nature recovery. And these kind of data are really valuable to help address some of these policy decisions. But flagging up the sensitivity of these models to different futures is something we need to explore further. And presenting uncertainty is challenging. Final slide, I think, please, Selene. So just to summarise a few key headlines from this, will hopefully stimulate discussion, and that biodiversity scheme data, I think, have got great potential to inform a whole range of policy questions and future modelling, as we've talked about across the different talks here. How you do this, whether you take a, say, space for time approach or look at population change, can influence the results. So you need to be careful about some of the modelling decisions that are made and be transparent around those. And it's really good as an organisation coming from the BTO, not CEH as the logo suggests, coming from the BTO, that good communication with those who provide the data and understand where the data come from with those who are doing the modelling is really important to ensure the outputs are robust. As I said, communicating uncertainty is challenging, and it's important to be clear about the assumptions and limitations that underpin those models. And there are some limitations to do that. But I think one thing, and this is kind of my final point really, is it interesting as a sector, and whether we'll get into this in this discussion now, if we can identify some of the key elements of environmental change and interventions that we particularly need to try and model across multiple taxa to help inform the future. Thank you very much. Thanks, Selene, for driving that.
Amazing. Thanks so much for all our speakers for a really interesting talk. We've had a number of questions come in through Slido, so we'll take some time to go through those now. I'm aware sometimes when people join externally, they can't always access the Slido link, so I'll just repost it now in the chat in case anyone struggled to submit their question. So I'll just go through the first question. So I think this one's possibly more towards Anita's work. The question goes, we won't get back to a pre-climate change state. So what should the target be, providing functions and services or preserving species? And if so, which species?
That's a good question. I suppose the short answer is I don't have the answer. And some of what we've done in previous projects to try to characterize that target is to make that an open question. What do we mean by a desirable future for people and nature? And there are kind of value judgments baked into that question. If I'm understanding your question correctly, where, for example, the Nature Futures framework, which is that IPBES framework that I was talking about, is a triangle that situates nature positive futures from somewhere in the triangle where each of the points represents different values for nature. And one of those points is nature for nature, where you kind of leave nature for itself and let it flourish, whereas others may be more instrumental values for nature, where nature's for society. And that may trickle down into some of those indicators that you're talking about of what it is that the target should be defined by and how it should be measured. But there might be others who are more kind of in the target quantification space who have more technical responses to that question.
Okay, thank you. Our next question, I think, would be for Rob. Could you give any specific examples of particular species affected by climate and land use changes regarding extinction in the SPEED project?
Yeah, frustratingly with the compositional models, they capture these like compositions much better, but they don't give you that species level detail in the same way as building a single model for every species would. But we can sort of infer and build that. There's a lot of work in the literature that focus more on specific species. So these disappearing environments in the uplands is likely the loss of some of these upland butterflies, because it's a similar number of butterflies that are lost under most of the scenarios, and it's all in this kind of same place. So it's like the Scotch Argus and some of the upland butterflies are likely to be lost, and similar with the birds, where often it's these upland species that if the climate warms, then suddenly there's just nowhere that's cold enough for them to inhabit their current niche. They might be able to adapt, and there might be some plasticity there or some adaptation that could happen, but that sort of depends on the rate of climate change. And then, yeah, for the plants, much more complicated, and we haven't really figured out which species might be in those communities that are going extinct. So there's definitely more work to be done on the species level, but our compositional level gives you this kind of different aspect of the combination of community and composition that leads to kind of the structures that we see out and about, I think.
Thank you. Our next question is that it was mentioned using these predictors or scenarios and working with governments. So are there any specific projects government is working on with using these predictors?
So is that a question just looking for a case of using scenarios to inform policy, period?
Yeah, I believe so, yeah.
Yeah, okay. I mean, I think there are probably others here who have examples as well, but there's two, I guess, from our side. Like one, there was a whole process with the Welsh government looking at different pathways, kind of land sharing, land sparing pathways, and that was very embedded within government there. There's also, James mentioned EVAST and ERAMP, where that's really embedded in the policy cycle, testing different outcomes of policy intervention scenarios is the language around that. So we want to try doing this. What would the implications of that be? And kind of, yeah. Others may have more examples as well, but it's definitely becoming more and more of a thing.
Thank you. And our next question is, we give higher value to specialist species and scarce habitats. How should we value different species in a dynamic future when many are on the move? Who decides?
Do you want me to perhaps take that? I think those are sort of societal questions, but obviously what we're looking to do with the science that we're doing is understanding the consequence of those different options, the consequences for ecosystem services, for society, and I think it's important not just to look within a UK context, but also understand actually what's going on outside of the UK. And certainly what we find with many bird species is and I think, and this, I think from what Rob said, potentially for some of the butterflies as well, potentially we become much more important for species that would have previously been in continental Europe. We've seen a lot of wetland species, for example, colonizing, and these are species that further south in Europe are very much under more pressure from climate change closer to the Mediterranean, as the wetlands there become really stressed, and therefore the UK becomes more, and the wetlands here and further north in Europe become more important. So I think it's important to have that international context as well, and that's where instruments like CMS, obviously Convention for Migratory Species, or large-scale agreements like the CBD, and obviously what happens in the European Union is really important to deliver that coordination.
Thank you. I think this next question is more for James and Rob. So, have any results from this work on projection surprised you, and how much do they support assumptions about species changes versus providing new perspectives? Who wants to go first? James.
I'll kick in quickly on that. And I think the one thing that's been most surprising about our climate change work is that often you end up with, particularly in a warmer climate, potentially more species that have got the potential to increase than those that might decline in a UK context. And that's simply because you've got a latitudinal gradient in species richness. So you tend to have more species located in the south than the north. Now, whether they will benefit or not is often, and I think as Rob's models show nicely, they're down to those interactions between habitat suitability, land cover change, and the climate change that we're putting on them. But that's probably the one thing that's been surprising coming out of our work.
And Rob?
Yeah, no, I was just going to add that I think, the thing we found most surprising was how widespread this change is. It seems under every scenario we do, you get huge amounts of change that we sort of have to start thinking about how we're going to deal with that, and these value-laden judgments of, is that good change, is that bad change? We don't quite have any handle on that at the moment. But we, you walk outside in 50 years and it's going to look really different, especially with the plants, where it surprised us, where these novel communities of like hot, dry, what's it even going to look like? We haven't got good understanding what might be even the habitats that exist in Great Britain in these new forms, and then that kind of underpins everything else. So there's all this change happening. How do we deal with that, and how do we understand it all?
Thank you. I'm aware it's 2 o'clock. Are you all happy to continue on? We've got a few questions left to go. Brilliant. Next question. Thanks for all the interesting talks. How do we validate our models on these novel scenarios, or what sort of validation approaches are you using?
So I think briefly for us, we tend to sort of take a cross-validation approach. So you remove some of the data from from your potential, and then predict to those that enable you to do that spatially. And for some of the models where we're predicting change through time, we can do that as well. And I think understanding the quality of the predictive power of those models is really important.
Thank you. Our next question, I think this is for James again. So, are there plans to make these tools or models more widely available in the future? So this is more, this is for BIMLA and Speed, I believe that the question's referring to.
Yeah, so we're looking to develop some scenarios that we're able to publish and put those out. So yeah, I think ongoing work in that area would, hopefully will enable us to do that.
Yeah, nearly all the data from speed is now out and about. It's like all the land use projections, all the climate projections are on the EIDC and can be used. And James Bullock, the head of speed, would really like it to be used more widely. And yeah, they're all there to be used, and yeah, hopefully are useful.
I think this next question is more of a general type of question. So this is a very excellent piece of work. Thanks for sharing. It will be useful in how we communicate nature conservation, as it brings much needed balance. So I think that's more of a statement, but any thoughts on that?
Oh, that's good to hear.
I'll go to the next question. I appreciate how biodiversity forecasting can inform urban planning. Can we discuss this further in terms of fostering positive change?
Yeah, and I think there's a lot of potential there. And if I'm very happy if you want, whoever put that in wants to get in touch with me, I can link you up with Kate, Gavin, Joe, who've led on that work. We're definitely keen to see that used more for decision making.
Brilliant. The next question is, given country context impacts which land use management is effective, how can decision makers be supported to navigate this evidence from predictions?
I was just going to say that, yeah, because they're exploratory, they're informative in a different kind of way, and they're sort of hinting at what these big levers are that could lead to change across land use. So for the biodiversity, we find that intensive agriculture and the amount of forestry have huge implications, and where that's positioned in spatially has huge implications for biodiversity. So it doesn't exactly get there yet as like more prescriptive, but some of the biodiversity pathways is trying to look at more like, what if we do this, how does that exactly play through the system, and lets us understand those decisions. But speed was more about what are the big levers that might be changing things in the future.
Thank you very much. Our final question is more specifically for Anita. So when working at large scale, e.g. EU project, is it advisable to engage wider public in scenario research, or is that approach suited to place-based work?
Yeah, it's a good question. And with any kind of scenario development approach, when you engage stakeholders, there's always kind of limits to who you can bring in, just also feasibility and resources and stuff. But for the European project, we engaged mostly people who are operating at kind of a European level of policy or business, planning, etc., across the different sectors. We didn't include the wider public per se, because we had a particular aim that required particular expertise. But I think, yeah, when you're talking about local place-based, then you have people who have a real stake in change on the ground happening on their plot of land that they manage. And for those kind of futures, especially when you're thinking about like policy pathways, it's really important that those perspectives are somehow brought into the conversation. Yeah, if the person asking that question wants to talk more about this, let me know, because it's a tricky boundary setting thing to navigate.
Brilliant, thank you. We've just had one final question pop through. If dissimilarity models work at larger scales and individual species models work at species level, what do we use to inform conservation?
Yeah, I think there's a clear role for both being informative in different ways. It's very difficult to model every single species. If you have to do it for all vascular plants, it gets very computationally complex and time consuming, and it's still hard to understand what's going on for every species. I think there are some groups where species approaches can tell you something more informative than a sort of community level approach, which James has shown with some of those maps for specific species that tell you something about the ecology of that species. So I think they're two different ways of looking at things and two different perspectives, and using both can give us much more insight in what's changing, how it's changing, and some of those interactions. So you do a single species model, sometimes that loses that context of the environment that it's in and the species that it co-occurs with, and all of that is important to understand biodiversity more holistically, I think. So yeah, I would advocate for both being useful for conservation.
Brilliant. That's all of our questions. So thank you very much, Anita, James, Rob, Chris and Selene for organising and giving a fantastic talk. And thank you very much for everyone for attending. Selene, I don't know if you wanted to give any more extra information on the TEPoP Festival. But other than that, yeah, thank you very much. And I hope you all have a lovely afternoon.
Thank you
very
again,
much.
our speaker.